Welcome to EDU World Space.
Okay, so here we're told that we have two workers, Sam and Joe, carrying a beam. The beam is 7.6 meters long and weighs 450 newtons. What are the forces that Sam and Joe are each exerting on this beam? So, in this instance, we're going to have to do two sets of equations because the sum of the forces will be equal to zero as the beam is not accelerating, but also the sum of the moments will be equal to zero because the bar is not rotating. So, our first equation is quite simply straightforward. Sam's force plus Joe's force has to cancel out the weight of the bar, which we are told is 450. So the sum of their forces is 450. Now, like I said, I know that the sum of the moments must be equal to zero. Well, in this case, I've gone ahead and labeled the left side A and the right side B. Let's say that the sum of the forces around B ought to be zero. Well, in that case, we're going to check the torques of each of these forces. So we know that Sam is acting at a distance of 6.6 away from B. The weight of the bar will be acting exactly halfway, so 3.8 meters away. And then Joe is acting 2 meters away. So my equation here would be 6.6 Fs minus 3.8 times 450, right? And minus here because the force of Sam is upwards, whereas the force of the bar is downwards. So they would cause counterclockwise and clockwise moments. And then Joe's force is back to being positive 2Fj because he is exerting a force in the same direction as Sam. And I am saying the sum of the forces and the sum of the moments should be equal here to zero. Okay, well, I can go ahead and substitute in that, well, I know that Fs is really 450 minus Fj. And once I solve that, I can go ahead and plug this in wherever I see Fs in the bottom equation. So plugging that in, I would get 6.6 times 450 minus Fj minus 450 times 3.8 plus 2Fj equals 0. And now I have one equation, one unknown. Multiplying all my terms out and using a calculator, I would find that Fj, the force from Joe, is approximately 274 newtons, which means going back to the top equation, all I do is 450 minus 274. The force from Sam must be equal to 176 newtons.